Meet Maya. She is in a comfortable chair far above the highest mountain on Earth, drinking water. A normal Tuesday. In 3 seconds, her water will attempt to leave the cup. Straight up. There it goes. The airplane lurches, the water lifts clean out, and Maya starts to rise too, until her belt catches her. The water did not attend the safety briefing. Outside, the sky is perfectly, insultingly blue. No storm, no cloud. People will call this an air pocket, a hole in the sky. The sky does not have holes. Maya, Captain Ada, and Flight 27 are invented. The physics and safety rules are real. 3 questions. What turns smooth air rough? How do you hunt something invisible? And what actually shoved the airplane Maya and her water? The drop comes last. First, let's rewind to departure and put the air back into the air pocket. Hours earlier, Flight 27 climbs out. Rough air is forecast, and Ada's first strategy is simple. Know the troublemakers, go around them. The big secret? Air is not nothing. You live at the bottom of an ocean of it, flowing, piling, crashing, thinner than the sea, invisible, which is rude. So this film cheats. These cyan ribbons are imaginary traces, a way to see wind. Down low, the sun heats the ground unevenly. Warm patches launch plumes of rising air. The air next door rises slower, or sinks.
If a rising plume is still just air, why does crossing one feel like a speed bump?
Because the bump is the boundary. Picture 2 moving walkways at different speeds. Stepping across jolts you. Air is no solid belt. Its boundaries bend, mix, and curl. Roughness lives where motion changes. Mountains run this at giant scale. Wind crossing a ridge bounces downstream like ripples behind a rock in a stream. Most of the wave is glassy smooth. Parts break and roll into tumbling rotors. Sometimes moisture snitches. Air rising through a crest cools and a smooth lens-shaped cloud appears, hovering downstream of the peak, not on it.
Is that lens cloud the turbulence itself, or just the only part we get to see?
Just the visible part. Steam over a bath reveals a draft that was always there. The steam is not the draft. Dry moving air makes no cloud, and no cloud measures roughness. No cloud does not mean no motion. Thunderstorms are the opposite, impossible to miss, and worse than they look. Their violent drafts spill rough air far beyond the pretty part with the rain in it. Up at cruise, rivers of fast wind, jet streams, slide past slower air. Where layers disagree, the boundary wrinkles, overturns, and sheds rough patches into perfectly clear sky. Patches, not the whole river. One family, one habit. Wherever air motion changes sharply across your path, the ride turns rough. Ada can dodge what she can see, but the patch waiting for Flight 27 sits in clear, innocent-looking sky. Clear air is not calm air. She needs better clues. How do you hunt invisible air? Ada's first tool sounds perfect. Weather radar, right in the airplane's nose.
So if the radar screen shows nothing ahead, the air ahead is smooth?
Unfortunately, no. Radar sees water, rain, hail, the wet heart of a storm. For that job, it is brilliant, and Ada draws a wide detour around the echoes. But dry, clear air turbulence gives radar nothing to see. A blank screen is not a promise. So crews stack imperfect clues. Forecast maps estimate where rough air should be. Fuzzy edges, always drifting. Pilots ahead report what they just flew through. Newer aircraft even measure the roughness they are in and share it automatically. The airplane ahead becomes an expensive weather sensor that also serves pretzels. The clues work. A report ahead warns moderate bumps at Flight 27's altitude. Ada requests a smoother altitude. Forecasts and fresh reports agree on one and switches the seatbelt sign on early. Storm dodged, layer escaped, cabin buckled. But no clue measures the air directly ahead, right now. Forecasts drift at the edges. Reports describe air somebody already crossed. Between one report and the next, a small silent patch grows on the route. That is the jolt from the beginning. Nobody saw it coming because nothing could. Avoidance has hit its limit. What remains is preparation, and preparation means knowing what moving air does to a wing. A wing cares about one thing: how air moves relative to it. Pilots call it the relative wind. An upward gust, seen from the wing, tilts the oncoming air up. The angle between wing and air, the angle of attack, just grew. In its normal range, a bigger angle means more lift, a smaller one, less. Force changes first, motion follows, always in that order. Real gusts are messy. One wing hit harder than the other, so Flight 27 can pitch, roll, bounce, and change airspeed in seconds.
In the drop, did the airplane really fall a long way, or did the cabin accelerate out from under Maya's water?
Your stomach cannot measure distance, only support, how hard the seat pushes back. An elevator starting down makes you feel lighter the instant it accelerates before it has gone anywhere. Turbulence is that feeling, minus the smooth ride. Now, the drop itself. A downward gust cuts lift, and the airplane briefly accelerates downward faster than gravity alone would pull it. The floor drops away quicker than the water can fall, so the water, still just falling, rises relative to the cabin. The room fell out from under it. Maya starts to follow. Her belt drags her down with the seat, its entire job keeping her moving with the airplane. The cup had no belt. So how far did Flight 27 drop? Often, barely at all. Moderate bumps may nudge altitude while the crew keeps full command. A dramatic cup is a terrible altimeter. The loose cup keeps travelling until something stops it, the real danger. In one 10-year study, turbulence caused 111 accidents on US airlines. Not one substantially damaged an airplane. The accidents were the injuries. 123 people seriously hurt, 97 of them flight attendants up and working. Now, the full ladder. Light is a shiver. Moderate is real bumps. Crew in full command. Severe can briefly overpower control. Extreme can make control practically impossible and damage the airplane. The comfort lives at the everyday end. Exactly why you can trust it. The airplane is in on the plan too. Before it may carry passengers, its design must prove it handles defined gusts and long stretches of rough air. Ada follows her rough air procedure and hunts smoother altitudes. Safety in layers, not a force field. Maya's contribution is one move. Belt low and snug whenever seated, sign on or off. It cannot stop the bumps. It stops Maya from becoming the cup. So, what actually makes an airplane suddenly drop? Not a hole, not missing air. Rapidly changing air motion changes the forces on the wings, and for a moment, the airplane rides along. Flight 27 lands. Maya is fine. The water has relocated, the cup has learned nothing. The sky outside looks exactly as blue as before, except now you know it was never empty. Nobody can switch the atmosphere off. Crews dodge what they can see, share what they cannot, fly machines built for rough air and buckle everyone in. Risk managed in layers. You live at the bottom of an invisible ocean, and it is always moving. Next time, your cabin shivers. Belt low, drink watched. Moving air, not missing air.